Hello, and welcome to Can You Do It Without a Schema? Data Modeling in RavenDB. How do you model data in a NoSQL setup? Is it really like reinventing the wheel? That sounds like a lot of work. Where do I even begin? Today, RavenDB CEO Oren Eini will talk to us about how easy it is to transform your data into a 21st century format using the document model. RavenDB is made to make your life easy, and he shows you how to remold your data without having to remold your thinking. In this webinar, you will learn RavenDB tools to facilitate document data modeling, how to model data in RavenDB, and examples of data modeling in RavenDB. If you have any questions at any time, click the Q&A button at the bottom of your screen, and Oren will be happy to answer them at the end of the presentation. Enjoy, and here's Oren.
Hi, everyone. First of all, David, in this webinar, any question that they raise, please let me know about this immediately and read them out loud so we can answer them directly. It would be much more efficient this way because this is relatively heavy material. The purpose of this webinar is to go over data modeling in RavenDB, and I'm going to make some assumptions here about the people on the call, and I'm going to assume that most of you are already quite familiar with how you're going to, you're already quite familiar with data modeling in general, especially as it's taught in universities, relational database modeling, and all of that. So the first thing that we need to remember is what is a domain model? And Fowler defined that as an object model that incorporates behavior and data, which is a very abstract way of saying that. I like to define things as the in-memory model and the persistent model. In the in-memory model, this is what you typically work with. This is typically what your code touches and modify. And the persistent model is what goes into the database. The easiest way to distinguish between them is that the in-memory model tends to be transient. It's not meant to be thread safe, but at the same time, this is where all of your behavior actually reside. Business rule, logic, those sorts of things, all of that tends to be applied directly on the in-memory model. If I'm creating a new order, I'm going to run the taxation rules on the in-memory model and not on the persistent model. The persistent model is how the data is structured. It's typically how you query the data, and it is of paramount importance for your system. But depending on how you're working with that, the persistent model and the in-memory model can be quite different. In relational database, this is usually caused because the model that you're using is unsuitable to the relational model. For a good example of that would be the humble order scenario. If I have an order, I also have a product lines or order lines, and that has to sit in a different table. But in my domain model, the way that I'm working with that in my code, I'm going to want to have that as a single object graph. That tends to cause problems down the line. But even if you're using something like RavenDB, which allows you to store full object graph in a document, that there is still some tension in the way that you model your data. And RavenDB has very explicitly made some design decisions in order to ensure that the impedance mismatch between how the data is stored on disk and how the data is stored in your application is as close to identical as possible. Another thing that is important to understand on the difference between these two models, you can modify the data on both ends. It is possible to have the in-memory model generate data that would be persistent, and you can write queries that mutate the data on the persistent structure. But a typical approach is that you query data into your memory and modify that and then save it back. That's the typical way that you will handle that in business applications. Now, the Bible of modeling inside of RavenDB is the domain-driven design. It's a wonderful book. Unfortunately, it's also very dry. There is also Jimmy Nelson's books about the DDD that explain that in a much more interesting fashion. But I want you to remember these three concepts: aggregate root, entity, and value object. Now, an aggregate root is something that has an identity in the model. Now, this is different than an entity, which is just something that has an identity. Let's talk about the difference between an aggregate root and an entity. In the online shop example, we're going to have an order and an order lines. And both of them are going to be entities. I can say, give me order line number 6. I can say, give me order number 50. This is if I'm using a relational database, because effectively I must have a primary key on the order lines table. On the other hand, in my model, I'm never going to say, oh, give me the order line 5. It doesn't make sense. In my model, I'm always going to approach an order line within the scope of its own parent order. In the domain-driven design book, Eric Evans talks about only creating references between aggregate roots. Even if you have entities that are encompassed by a single aggregate root, you should only have one of them. With RavenDB, the situation is quite different. We don't actually have the concept of an entity. Or rather, to be more exact, the division that we typically do is that we have a document, and a document is a one-to-one mapping to an object graph that is an entity inside your application. Now, remember, notice that in this context, an entity would be the full object graph. An order document, and just to give you some idea, let's go and talk about this. Here is an order. Why can't you find it? Okay, something is wrong and it doesn't like me today. Oh, that's lovely. What actually happened is that I'm using a developer instance and I ran out of CPU credits. That's because I tested everything before the model, before the webinar, and I basically exhausted everything. Let's go and look at this here. Here we go. Same thing. Now let's see something slightly smaller. This one. Okay. Now you can see this guy. And this is an order document, and you can see that we have here the lines embedded directly inside it. When we create an entity from this, all of this object graph is going to be hydrated into a single, all of this document is going to be hydrated into a single object graph, but it's going to be composed of multiple objects in memory. We'll touch that in more details later. But an interesting observation about RavenDB, you can only have references between documents. So that matches the aggregate root section. Let's look here. Here is the first or zeroth line in order 8 to 8. But I have no good way of actually referencing this. If I want to have a reference, I must have it to another document. So this matches very closely how aggregate roots work in the domain-driven design model. Now, here are the rule of thumbs of modeling things inside of RavenDB: isolated, independent, and coherent. And basically, they're very simple. The idea here is that you can take a document and do stuff to it without having to do stuff for anything else. And it's easier in many ways to think about this the other way around, to think about this using negation. So a document is not coherent if, in order to understand it, I need to reference another document. A good example of that would be an association table in a relational database. It's meaningless unless you join to the other tables that it relates to. A document is not isolated if every time that I modify a document, I have to also modify a different document. And a document is not independent if it can't exist on its own. An order line document, as a good example, is a good case of a document that is not independent. An order line always exists within order. It's right there in the name. So those are the rules that you want to keep in mind. It's really easy to tell if you have violated them. So that's good. But the end result is that you want to get into a point where you can look at the document, you can make sense of it, you can modify it on its own without touching anything else, and it doesn't break any other part of the system. Another really good thing to remember about a document in RavenDB, it's a transactional unit, which is really interesting because RavenDB supports multi-document transactions. So what do I mean by saying that this is a transactional unit? A RavenDB document is mutated as a single unit. Two operations to modify the same document will always run in some sequence of events, one after another, in a serial fashion. Note that two modifications to different documents may well run concurrently, but from the point of view of RavenDB, you're only modifying a single document at one stage at a time. Why does it matter? It matters because this is how you deal with business logic and concurrency and the notion of what changes make sense for a document. I'm going to come back to the orders again, and let's say that I have two concurrent operations. I'm going to want to change the shipping address of a document, and I'm going to want to add a new line item to the order. Now, try to imagine the following sequence of events. In one thread, I'm setting the address, which means that I need to run the business rule of make sure that I don't have any line item that I can't ship to this address. And on another thread, I have add an item to the order, which means run a business rule, make sure that the new line item is valid to send to the shipping address that is specified. Now, in a relational database, we would typically be mutating different rows in many cases on different tables. That means that we would have to do something called coarse grain locking in order to ensure that we haven't violated the consistency rule in our domain. With RavenDB, the consistency rule is the document. And in most cases, if you have optimistic concurrency, it would just work and one of those operations would throw. If you don't have optimistic concurrency, then the last right wins rule will basically apply. And one of those would be valid, which is actually a good thing because you maintain your consistent state. You haven't made two independently valid modifications that ended up in an invalid state for the system. So the transaction unit is the term that the domain-driven design book use. I tend to prefer a consistency unit, again, because of the confusion with transactions. An important issue about isolated. People tend to think that isolated means, oh, we're only going to modify a single document at a time, which is not the case. A good example of that is the classic transactions example, moving money from one account to another. This is absolutely one case where I want to have a transaction, but it doesn't mean that those two documents are always mutated in the same way. So that's the case. Is it possible to mutate a document without touching anything else? It's not required to only mutate one per transaction. Now, I gave a lot of example on the online shop. So here is the Northwind example. This is also the sample data that they have in RavenDB. So we have order lines, and products. Now, this is probably the most simple database model I could think of. And even so, you can see that there is quite a lot of going on. In order to properly display an order, I might have to touch all of those documents. With RavenDB, on the other hand, all of that is actually going to sit in a single place. This guy, the order document. But there are a lot of subtle things that are going on in this model that I want to touch. So let's talk about the first one. This is the order model. It's stripped down significantly, but you can see a few things that are really interesting. The first thing is that we have a string ID. All IDs in RavenDB are string. The reason for that is that this allows us to create human-readable, such as orders A28A, which is very human-readable, document ID. We can create them in a distributed fashion very cheaply. And it also allows us to do some really nice tricks, which I will talk about at the end of the webinar. Now, this is a reference to another document. I need this guy. You can actually look at the related and see some other interesting data. But all references to other documents in RavenDB are always expressed as a string. Now, they're expressed as a string both in the database and in your domain model. Why is that? I have spent enough time on the Hibernate codebase to know how to create transparent references. I could have put a company here instead of a string. Why shouldn't we do that? And the answer to that is that this is probably going to be really expensive tripwire. One of the things that I've found in many consulting on the performance of an Hibernate is that people, if this is the transition between documents or entities isn't obvious and if it isn't explicit, you're going to have to do that. You're going to end up doing that in such a way that it's going to happen behind the scenes. And happening behind the scenes means that you're going to do it without noticing, which ends up being really expensive to do. So the idea with RavenDB and the way that we express the model to the client code is that we directly expose associations between documents as primitives, as strings. This is in order to make sure that you very explicitly are aware when you're traversing the boundary of an object. It also means that in many cases, if I hand you a document, an object graph that is represented by a document, then it's very easy and cheap for you to just work on that. You know that everything is safe to touch. Contrast that with a rich domain object that is backed by an Hibernate or entity framework, and any property that you touch, any complex property that you touch, may end up being an expensive query to a remote database. The next thing is, how do we handle nested values? In this case, we have the address, and this is just a class. And here, this is what it looks like. So now we have an embedded value inside the document. But why is that? What's going on in here? So the first thing is that previously a different document is a string. A complex value inside the same document is represented in the model as a complex object. That's why I'm talking about an object graph. And the idea here is that this allows me to organize the data much more easily and cheaply than usual. And I think that we have a question. And Rastislav Svoboda, and if I killed your name, I'm really sorry. Then he asks, should not it be customer ID? And I assume that you're talking about the company. So that is a convention. You can call it customer ID. RavenDB doesn't care. The idea here is that the naming convention is up to you. And we don't care what the name is. We don't care what how you want to call it. But sometimes you would call it company ID. Sometimes you would call it a reference, and not much of other stuff that depending on how you're going to work with that. The key from my perspective is that this is a string and not an object, because that expresses the division between documents very clearly to you. Coming back to ship to an address, now we have a nested object, and it works quite nicely for us. However, there is an issue here. What happened when this changes? Now, if I'm going to look at here, okay, so this is somewhere in Switzerland. I'm not going to even try to pronounce that. And this belongs to company 68. And now we can see something really, really interesting. Look at this value, which is something 237, which that I can say. And look at this. This was sent to somewhere entirely different. But isn't that a bad thing? I mean, now we have inconsistency in our data. When we created the order, we had copied the address to ship to from the company document, and then we change the address to ship to on the company, but it didn't change here. And this is typically where you run into the false issue that people have with document-based modeling. With the idea here is that you don't have come on, I'm blacking out of that. When you split the data, I have a total blackout right now. Let's answer the question, and hopefully I will remember what it's called. Yes. Okay. With company reference, the RavenDB has a concept of referential integrity. Okay. So referential integrity in RavenDB. The answer is no. RavenDB does not enforce referential integrity. It supports a lot of stuff that looks very much like it, but we don't do referential integrity because we're a distributed database. And in many cases, distributed database can't assume that the data is present in the current node. Okay, yes, and Wallace, thank you very much, denormalization. Thank you very much. I had a total blackout. So the problem with this approach is that this variance normalization, we modify the data in one place, and now we have to modify in all other places. And the answer to this is that I explicitly chose this specific example. And this specific example is that this value and this value are not the same. This is the address of the company. This is the address that the order was shipped to. Even if in 99.9% of the cases this is the same, companies move. And if they change their address, that means that doesn't mean that orders that already has been shipped or in the process of being shipped need to change their address. This value represents what this particular instance of order is going to. So that's very important. If we had a reference, if we have something like, this, then we could go and change the address and have it apply globally. But that would actually be the wrong modeling decision here. We want to have it here. In a relational database, you run into, in more complex systems, you run into the concept of temporal data. I used to work on a payroll system, and one of the complex stuff there was that you had data that was a timestamp. Your salary from January to July was X, but then you got a raise retroactive 3 months. So now when you looked at the data, it was also important to know from when you looked at the data, and that was a huge mess. And a lot of that came about because they tried to model the data in a relational way with proper normalization. With the way that you do it with RavenDB, you just say, oh, this data is part of this document. It shouldn't change globally, so you just stick it directly as a value object. Notice that in a relational database, in the term value object is typically talking about primitives. Sometimes you would have a money object, which is a combination of two columns. But in RavenDB, a value object is anything that is not a document. For that matter, we also have this one, the lines. The lines is simple. Oh, I just have a list of values. That's it. But the key here is that because I can have a really complex object that can include arrays and nested objects, my freedom to express myself has become much greater. It also means that certain features, for example, I want to add tags to a document. If I want to do that, all I need to do in RavenDB is do this. Stuff like that, and now I got tags. Everyone is happy. However, what's the issue here? The issue is that if I was trying to do that in a relational database, okay, let's create an association table, let's create a tags table, let's do joins all the way in order to query that, stuff like that. All of the changes in RavenDB tend to be localized, not globalized. Another important feature is that I don't have to have the same structure for different documents. I can do things like this. And it sounds trivial when I'm saying that, but it's actually really quite a profound difference in how we're doing things, because it means that I can change the way I'm looking at things. Instead of, okay, let's define something globally that applies to everything, I have to take everything into account, and the schema means that I have to predict everything. I get to be much more flexible and agile. Oh, let's just run away with this. And the database is going to be flexible enough in order to get things to the way that I want them to be. Okay, so right here, what I got is nested objects. This is a reference for the company that I have. What I have here, this is the other side of this. Let's go from all of the orders of a company. And the interesting about this is that this is not a property. There is no way in RavenDB to have an orders property on a company class. Instead, you have to very explicitly make that into a query. And why is this important? This is important because, again, this forces very strict and explicit queries in the domain, in the code that uses that. A lot of the design of RavenDB was around the modeling, the way that you approach data. Not necessarily the features, but how do you make sure that the operation that you do in your domain, in your application, are explicit and obvious. Now, here is an interesting problem. How do I handle a many-to-many association? And the classic example that I have here are tags. So I have, in this case, I have many tags and they can be associated with many orders. The example that I really like here is users and groups. And the way that this is handled, there are, in a relational database, you would tend to have an association table. That tends to grow very large and require a lot of maintenance on that. With RavenDB, you would typically model that as just a property, just like this. Now, the question here is how am I actually going to handle that? I have one option of doing that is like this. Store it as an array property inside the order. The other option, would be to do something like this. So the association would be maintained either on the tags or on the orders. And there is almost never a good reason to do it this way. At least I can think of any good reason to do that, because in most cases, you're going to have a lot more order than tags. So you want to store the many-to-many association on the short side, on the smaller side of the association. In a users to groups, you would have a groups property on the users. When you have a tagging system, the tagged object is going to have a tags collection. Okay, now I want to touch on a few examples where RavenDB can significantly has features that can make your life a lot easier. MapReduce lazy it includes, and let's talk about this. So let's look at this. Let's see if we got enough. Okay, so now you can see something really interesting. I'm asking, okay, from orders, group by, blah, 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 give me some results. I'm not seeing any model in here. Where is it? Why is it interesting? And the answer is quite simple. This is cheap. If this is cheap, it means that I can query that easily, cheaply, without having to do a whole bunch of stuff. In turn, this means that I get to very easily take advantage of that in my domain. Instead of having to do a whole bunch of stuff behind the scenes, nightly, weekly reports, and stuff like that, I can just do it like this. Another important modeling option is this guy. And I actually have a full blog post that explains this guy. But basically, I have an index. The index is a MapReduce one. It goes over all of the orders. For each of the orders, it goes over each of the lines. And it creates an association between a product that was purchased in a particular order to all of the other products that were purchased in the same order. And then we go by the result and do a whole bunch of other stuff. From our perspective, the most interesting thing about this is that I can ask what products were purchased with this. And I get a full list, ordered by the frequency. So apparently, Boston crab meat and Cambrai something are the most common things that are purchased with products one, which is chai. I'm not sure this actually holds up, but this is what the sample data set tells me that it happens. So this is a tiny bit interesting in terms of modeling, because the cost of querying means that you can do things differently. You don't have to have a property that you maintain in your domain model. You can just let RavenDB handle that. But the product accommodation and other features like that, where you have MapReduce indexes that go over your data and produce interesting result out of that, can be a lot more interesting to work with and explore your domain and things of this nature. Now, I want to talk about the customers page. I have a customer page and I need to show some data. Let's look how it works. So let me just run this. And we're going to run, we're going to get some data out. Let's see what we're doing. First, we're getting the company by ID. Then we're counting the number of orders for this company. We're getting the last 5 orders. We're printing the orders, and we're finding the set of products in the recent orders. We load them, we print them, and then we say how many times did we hit the database server. I'm going to go here to Traffic Watch. I want to see again what this looks like. Now you can see all of the queries. Not really that interesting, I would admit. Here we go. Now, this is not interesting, but this is. Now I'm going to run this with line. Now I'm going to run this same code 3 times. Okay, here we get some results. Again. And now we can see something really, really interesting. You see the 200s? And now we have 300s, 304. 304 is an HTTP status code, which means not modified. Why do we have not modified? RavenDB does automatic caching for us. When we are writing code, when we're writing queries to the database, RavenDB keeps track of that. If we issue the same query, it sends the data to the database and says, hey, I already got it. I don't need to, and not only do I have that, here is the exact version that I got in my cache. And the RavenDB server then says, you know what? Nothing changed. Instead of me going to the disk, figuring out all of the data, running the query, all of that, I'm just going to tell you, hey, nothing changed. And you will still have to go to the server, but we get a 304 back. Now, this matters if the number of results or the size of the results is significant, because that means that we can drastically reduce the amount of network traffic that goes through. Let's clear this. I can also do this. And here I'm telling RavenDB something quite different. I'm telling RavenDB, run this again. And that's interesting. You might not have seen this happening, so I want to make sure that we do this properly. Let's run this. Okay, so here are the queries that I made. Notice that here I have 0. I'm going to hit enter. You saw that this changed, but this just appeared magically. And again, very quickly, very magically, things appear. And I have no more queries here. Aggressively caching is taking the cache one step further. We're saying, you know what? I'm going to need to hit the database again. I'm instead of hitting the database to just find out if the data has changed or not, just do it the other way around. Just serve directly from the cache. Now, just to give you some idea, this guy is in US East. I'm in Israel right now. So you saw the latency when we started running the query the first time. Now, let's run the query again. And there is a noticeable amount of latency. Now, I'm going to go here. Let's find companies number 1. No. Companies number 1. And you're now called 2. And now I'm going to run again. And here is the change. Aggressive cache means shifts the responsibility. Instead of the client always checking again and again and again if the data has changed and only benefiting from the reduction in network traffic, in the network bandwidth, not traffic, because we still have to go to the server, Aggressively cache means, no, let the server notify me when something changes. This is using the changes API, and it means that instead of the client going and asking the server monitors all of the clients. Whenever something changes, they let them know. So we get the benefit of both worlds. It does mean that there is some latency between something changes on the server side and the server notifying the client about that. But for the most part, that's why you actually told us that, yes, I can tolerate that. So caching is a very important feature. It is on by default. You have to do nothing and you benefit. Aggressively cache, you have to explicitly subscribe for. Now, I mentioned that RavenDB was designed upfront in order to make things easier for business applications. So let's look at this. Right now, I have to make 2 queries to the database in order to answer that. Going to the database is expensive. I can also do it like this. Now, what I've done here, I use the, yes, that's correct. I don't have an I anymore. What I've done here, I've used the statistics feature of RavenDB. And the statistic feature is something that is already being sent on every query that you make. See? And this is the number, the 6 items that I have. Now, statistics are being sent on every query that you make already. So it's not like we have to do additional work on the client or server side to get them. This just exposes them to you. This means that this very common scenario of give me some results and get me the total number of results for this query is right there at your hands. So that's good. Now, let's see. I'm asking for get me all of this, and that get me the company, then get me the order, then get me related product. Let's see how this works. No, that's not the one, this one. Okay. For orders, where company is this. Here are the 6 results that I have. Now, I can do something like this. And this is the includes feature that I talked about. Includes basically give me 2 channels for the request. Here's one channel of all of the included products, and here's the actual results. Why does this matter? This matters because now I don't have to go to the database twice. I can do that in a single round trip to the database. So let's see this. In here, I'm going to say, there we go. So what I have here is, okay, let's get the products. Now, remember that previously we had 4 calls here. Now we're supposed to go down to 2 requests. Why is that? This is the first request, get me the company. Then get me the most recent orders. Or actually, this is not even recent because we don't do an order by, but oh, I removed the properties. Let's do it like this. Never mind. There is a order at or something like that. I just remove properties for this, so I have to bring them back. Okay. So now I actually get the most recent orders. And this query gets quite busy, right? We're saying, okay, get me the statistics so I can have the total number of results. Get me the related products from the lines, where for this specific company, order by descending, take 5, all of that. And now I'm running the same code, getting the same unique list of products, but in here, I'm not touching the database. Why is that? Let's run the code again. This time, let's go to Traffic Watch. And this is the actual query that we run. You can see it. Go and include this range, which means that here, I don't have to touch the database. We still have 2 requests to go. We can resolve that using this feature. And I'm going to have to move it to here. So let's see how this works now. Now, I'm not making a query. I'm using lazy. And I can that's the whole change that I need to do. And we're running the code again. Now I made a single request to the server. You can see it here. One is to get the companies, one is to get the query itself. One query to go to the database without any additional work necessary. Now, why am I talking about this in the modeling discussion? I'm talking about this in modeling discussion because this is important. This is related to how you structure your data. Because being able to log the data in a single round trips mean that the performance of the entire application go up significantly. I mentioned that document is a string, and that matters. It matters because it allows you to play certain really interesting games. To start with, all sorts of reference data become very easy. Oh, I want to store the states. I want to store all sorts of drop-down box, stuff like that. Store them, store them in a document like this. And the idea here is that even if you have complex reference data, that maps very easily to a document. It has a well-known name, and you can just run with that. Use something like aggressive caching here, and you won't even have to touch the database in most cases. The other option that we have are for complex or meaningful documented deals. For example, here are the transactions for this account for today. And the idea here is by using these sort of features, you are able to build a system that can model the the structure of the business. And that sounds very weak. So let's talk about things in more concrete fashion. If you have a business bank account, then you're familiar with the notion of a business day. And in this case, what we're going to say, all of the transactions on a particular business day go to this particular document. And remember what we talked about being a consistency boundary? This is exactly what happens. And this allows us to model the business consistency boundary very easily. If we had a separate document for each transaction, then that would imply then that we need to somehow create a coherent consistency across all of the transactions. But if we have a single transaction for a business day and the business rule says that only the most recent business day is where we actually take actions, then that makes our system much easier to model. And with that, this is the time for questions. If you have any questions, feel free to throw them on the Q&A. And we got that. Felix asked about a specific issue. Thank you very much. I don't get all of them in my head. Do you know which one it is? I can't actually click this one. That's not very helpful for me. What's the title of that? What is it about? Okay. Oh, artificial document IDs are something. So artificial document IDs are a feature that is related to output collection in MapReduce. This is something that the design work on that has been done, and I think that is going to be moving into actual work in the near future. Near future mean weeks, not months. But beyond that, I don't have the schedule for this at this point. More questions? Okay, so Adrian is asking, MapReduce is cheap to query, but is it cheap to maintain? And the answer is, it's really, really cheap to maintain. Go here. No, you know what? Let's look at something interesting. Here is the product recommendation example, and product 1A has 3 products. Now you can see something interesting. Here, this was sold 38 times. Here, the total sum across everything. And here are the maps across everything. Now, the key here is that whenever we have a new order for product 72, it's going to go here and then recompute that. If we have enough work, then let's see if we can actually generate this, not this one. So what I'm doing right now, I'm generating enough load to hopefully cause the system to move into the next stage. But for now, while this is running, we're going to answer other questions and let it come back to it. But the quick answer is yes, it's cheap to maintain. Leonce is asking, what happened to existing document when your document POCO gets new property added to it? Do you have control over default values for existing documents? And this is a really interesting question. And the answer is yes. First of all, when you load a document and you add new properties to it, then it just gets loaded. And the new properties that you have get whatever default value you already define in your own domain. The interesting thing from that perspective is that you just define whatever in the constructor, whatever default value that you want. You can use a query like this, like a patch, to add new fields to the existing data. what in most cases easier to just have it done in your code and just work it this way. Okay, I think we are done here. Let's go back to the MapReduce visualizer. Okay, now this is obviously going to take a lot longer to run, but we got this right. Okay, notice that now we have a tree structure here. We have 473 products here, 1,800 here, and another 3 leaves here. Whenever there is a new item for product 42, it goes first here, recompute this value. So this would be recomputed. Then this would be recomputed. So the idea here is that the cost of doing this update is OH, which is the height of this tree, which tends to be very efficient. More questions? And for once, I have to point out that I'm right on time. I'm going to give it a few more seconds if you have any additional questions. If not, feel free to ping us through the mailing list. Thank you very much for showing up today. Goodbye.